The amplitude of a particle in simple harmonic motion is A. Angular frequency is 4 rad per second. Find the shortest time that particle takes to have displacement of root 3 over 2a when it is at amplitude point.
Alright, let's get into the equations now. Our first equation, that is x equals a sine omega t. Here x is the displacement from the center here, and a is the amplitude sine omega t. So there are 4 phases for a simple harmonic motion. So 1, 2, 3, 4, it comes back to the original positions. And the time period t equals 2 pi omega. Using these two equations, we are going to find the answer. So here they are telling a small, very special part here. Find the shortest time that the particle takes to have a displacement this much when it is at amplitude point. So if you miss this point, you're gonna go for a different path for the answer, so you might end up with a wrong answer. So here, so they're asking us the time for us to come from final here extreme n to a certain point here. So they're asking this time, right? So by using this equation, we are using here in this equation, we cannot find time from extreme n to here. So we can only find time from center points, from the middle point, time from middle point. So from our equation, we are getting this time x. Let's say it's x, this, let's say t1 here, t1 time. So they're not asking t1 time, they're asking the time, let's say t2, from extreme n to this point. So our plan is to find t2, but from our equation we can find t1. So how do we find t2? Somehow, let's say we have found t1 now. So to find t2, we need to know the total time, right, from extreme n to the middle point. That is, yes, some part of the total time period. So how do you find the time period using this equation? Let's get into the question now, right? So initially we have to find the time period, right? T equals 2 pi over omega. Here omega, we are given omega, so 4 pi, so we are getting 1 over 2 seconds, right? So for one part, there are 4 parts. So for one segment from one extreme end to the middle point, we get time as half into 1 over 4, that's 1 over 8 seconds, right? So we have 1 over 8 seconds. So now our plan is to find the time from here to here, this point. Right, let's apply x equals a sine omega t. Right, here x equals root 3 over 2 capital a sine omega t. So now you can see this capital A cancel off. So sine omega t is root 3 over t, root 3 over 2. So now we know sine 60 is root 3 over 2. Then omega t, it has to be 60. So let's write it from radian. That means it's pi by 3. So omega we know it's 4 pi. So into t, pi over 3. So we get t equals pi over 12, 1 over 12 seconds. But this is not the answer. You can see this answer is also there. But this is not the answer they are looking for. They are asking us to find the time from extreme n to this point, right? So we have to subtract from the initial value we got. So that's 1 over 8 minus 1 over 12. So common denominator, we can take it as 24. So it's 3 minus 2. So we got 1 over 24. So fifth answer we are getting. Right. Students, if you think this is valuable and helpful, share it with your friends, study together and win together.